Alrighty, so we are going to be working with partial fraction decomposition today. This is actually a pretty complicated topic in some other classes, but the nice part is the AP Calculus exam only has you do the most simple form. They only have you decompose partial fractions with non-repeating linear factors, which is a mouthful, but it's something you don't need to know. Basically, it just means that anytime you have a fraction, it'll factor into nice linear factors, so x minus something, x plus something, no x squareds, no x cubes, and it'll always factor nicely. So it makes your job really easy. Also, you'll notice that none of the factors repeat, because sometimes if you get, for example, like a fraction 2 over x minus 3 squared, the decomposition's a little bit trickier. So we are just dealing with the most basic of fractions, and what we're going to do is essentially rewrite the fraction, a large complicated fraction, into something that's a little bit easier to deal with so we can actually take the integral. The fractions we're dealing with will have some sort of polynomial on top. It could just be an equation as easy as 2, or it could be 2x, or 2x squared plus 3x plus 6. Doesn't matter, it's got something on top, and that really doesn't have much to do with the entire process. The nice part is, though, what will happen is eventually you should be able to make the bottom of your fraction look like just a bunch of factors. You'll be able to factor it. It factors super easily, and everything I've seen on past AP tests really just brings it down to 2 factors. X minus something, x plus something, x plus something, x plus something else. It doesn't matter. But either way, partial fraction decomposition tells us that that fraction, this nice big giant fraction right here, will break down into some constant over the first factor, plus another constant over the second factor, plus as far down as you want to go. I ended with z, but you could go an infinite number of times down there. So, how does this apply? Let's take a look. First example. Let's say you're asked to integrate something like this. U substitution won't work. It wouldn't replace anything enough to make things easy. But I think if we split this fraction apart using partial fraction decomposition, it might help us along the way. So it'd be something like this. We would say the fraction 2x over x plus 2 times x plus 1 will decompose into some constant a over x plus 2 plus some constant b over x plus 1. Okay? If we wanted to go further, and we do, we need to actually figure out what a and b are. In order to do that, one of the tricks when you're working with these rationals, these fractions, is we try to give everything a common denominator. Currently we have x plus 2 in one fraction and x plus 1 in the other. To give them common denominators, this would need an x plus 1, top and bottom, and this would need an x plus 2, top and bottom. And for all intents and purposes, now that we've done that, we can ignore the denominator and just look at the top. So, starting some sort of new equation here, we get that 2x is going to be equal to a times x plus 1 plus b times x plus 2. From here, it's really just a matter of choosing x values that make your life easy. For example, we could choose something like x equal to negative 1. And I'm picking that because that will make this factor, along with a, disappear and let us solve for b. So it would tell us 2 times negative 1 is equal to a times negative 1 plus 1 plus b times negative 1 plus 2. Simplifying a bit further, we find negative 2 is equal to, well, that's zeros, plus b times 1. And I think simplifying, we find that b is negative 2. Alright, not too bad. We can use a similar process to find a. So in order to find a, we want to zero out the second factor, so let's choose x equal to negative 2. Put a little divider here. If we choose x as negative 2, we find 2 times negative 2 is equal to a times negative 2 plus 1 plus b times negative 2 plus 2. Simplifying a bit, negative 4 is equal to negative 1a plus 0. Dividing by negative 1, we find that a is equal to 4. Okay. So let's go back to our original problem. We find that the integral of 2x over the denominator x plus 1 times x plus 2 can actually be rewritten as the integral of, let's see, a was 4, so 4 over x plus 1 dx And then notice b is a negative number, so we might as well just say minus the integral of 2 over x plus 2 dx. Working a little bit further, we can factor out the 4. So integral 1 over x plus 1 dx minus 2 integral 1 over x plus 2 dx. And we know whenever we see that pattern of some constant on the top of a fraction over x to the first power, we're going to have to incorporate that natural log. So we're going to use the absolute value. We find natural log absolute value x plus 1 minus 2 times the natural log absolute value x plus 2. And of course, since it's an indefinite integral, we need the plus c at the end. And for now, we'll leave it right here and call it a good day. All right. Second problem, and both of these are taken from past AP tests, so it's fairly realistic. These aren't super complicated problems. They just want to make sure that you actually know how to decompose a fraction. Okay. Second problem, scrolling on down, we have something that looks like this. The first thing you should notice when you take a look at this is that the denominator of this fraction isn't in factored form. So we might as well factor it. We see that it's the integral of 1 over, let's see, this probably looks like x minus 4, x minus 2. It's not looking too bad now. Of course, we still have a fairly complicated denominator that we should break down. So maybe we'll take a little sidebar over here and see what happens. We want to decompose the fraction 1 over x minus 4 times x minus 2, and we know it decomposes into a over x minus 4 plus b over x minus 2. It doesn't matter where you put a and b, you can switch them. The order of the factors is just multiplication, so it's totally up to you. Giving them common denominators at this point, we'll note that we need an x minus 4 here, and I'll squeeze in a friendly x minus 2 right here. Common denominators, so just deal with the numerators, and that tells us that 1 is equal to a times x minus 2 plus b times x minus 4. Let's choose appropriate values of x. The first one to make the a's cancel out or go to 0 would be x equals 2. And that tells us 1 equals, we can see that the a's go away, equals b times 2 minus 4. So 1 equals b times negative 2, which tells us that if we divide by negative 2, b equals negative 1/2. We're like, that's not really looking great, a fraction within a fraction, but we'll come back to it, not too bad. Dealing with the second one, let's start over and choose x equals 4. That tells us that 1 is equal to a times 4 minus 2 plus 0 at the end. That b term will cancel out. So we get 1 equals 2a, and in a similar vein, we find a is positive 1/2. Alright, well, let's see what that does for us. Maybe before I tackle the integral, we'll see if we can simplify this, but it doesn't really matter. So, just a little sidebar here. 1 over x minus 4 times x minus 2 is going to be equal to 1/2 over x minus 4 plus, nope, wait, we have a minus, so we might as say minus 1/2 over x minus 2. Now, there are a couple different ways to think about this, but it's totally okay to rewrite those fractions like this. We could say it's 1/2 times the fraction 1 over x minus 4 minus 1/2 times the fraction 1 over x minus 2. And it's really no different than if this was like the number 6. We could totally rewrite this as 6 times 1 over x minus 2. 6 is just a number, 1/2 is just a number. Don't let it throw you off. You can still factor it out to the front. So we end up here, and this is where things get useful. If we have that integral in front, because that's what we were trying to figure out, we can say that it's equal to the integral of all this with little dx's to make life better. Maybe we can separate this into two pieces. We find it's 1/2 integral 1 over x minus 4 dx minus 1/2 integral 1 over x minus 2 dx. Let's actually take the antiderivative now. It's that same pattern of natural log, and you'll find that natural log pops up in the mass majority of these cases too. But 1/2 times the natural log absolute value x minus 4 minus 1/2 natural log absolute value x minus 2 dx. It's sometimes the case that you'll have to apply some natural log or some log rules here, so this is good practice. Notice we can factor out the 1/2 to the front, and that leaves us with natural log absolute value x minus 4 minus the natural log absolute value x minus 2. And we'll have to clean a few things up. First, I put a dx here, which seems ridiculous, and it is. Second, we need that plus c since it's an indefinite integral. Last but not least, whenever you have one log subtracted by a second log, we know that we should be able to divide their insides. So I think maybe the most condensed or simplified form of this would be something like 1/2 times the natural log, large absolute value, x minus 4 over x minus 2, close the absolute value, plus c. This actually turned out to be the answer on a problem that isn't super bad, but required you to go a little bit further. And that's all I have for partial fraction decomposition. Expect one question on it on the multiple choice section of the Calc BC exam. Thanks for watching.